Assalamu alaikum everyone. Welcome to the Eduverse, a universe of learning. I hope we all are doing very well with your family, with a good health and joy. Assalamu alaikum. Today we are going to talk about the physical quantities and its units. Actually understanding the language of physics. So it will be the today's topic. So let's start about it. Introduction. Why unit matters? Like first of all, we know if we hear about the physical quantities and its units, then here the question arises that why we need of units. Like if we have a quantities, so why we use units with it? As physics is all about measurements, like measuring length, measuring weight, measuring speed, measuring time, all that. So imagine if somebody told us that a car is traveling with 6, then we will ask him that what 6? Like 6 kilometer per hour, 6 meter per hour, 6 miles per hour, or 6 miles, what that? So in other words, if we don't use units with the number, then that number is totally meaningless for us. Like the 6 over here is totally meaningless for us. Like we will say that what's the mean of 6, as I have told you. So it helps us to describe the world accurately. Like if we use the units with the physical quantities, it becomes a full meaningful and will convey a accurate information, information to another person. Like if we tell somebody that the car was moving with a 6 kilometer per hour, then it's a correct and full information and a meaningful talk that the other person get it that yes, a car is moving with a 6 kilometer per hour speed. So that's why the unit is totally very much important in the physics and the physical in the measuring of the physical quantities, because without it it's totally meaningless. So that is not your job for us. So what are physical quantities? Here I have definition over here for you that a physical quantity is a measurable property of the nature. Here I want to add another definition about the physical quantities. Physical quantities are those quantities which can be measured. So which can be measured is actually the physical quantities. For example, if we have a length, so it's a measurable. Yes, we have something in a meter, something that. So something that can be measured. Length can be measured, mass can be weighted, that is also can be measured. Time traveling, time interval, all that is measurable. Is the same as for the temperature. So all these are the example of the physical quantities, because all these can be measured with a different scale and for the different purposes. Types of physical quantities. In general, we have two types of physical quantities. The one is called as fundamental quantities, it's also called as the base quantities, and another one is derived quantities. In a big picture, if I told you in a simple word that fundamental quantities, it's actually looking for its name. Fundamental means that the very basic quantities. These are actually that quantities which cannot be broken into further other quantities. These are the basic and the building block for the other, for the foundation of the other physical quantities. Like if we have like for example, we have the length, mass, time, etc. Are the examples of the fundamental quantities. Now about the derived quantities. What are derived quantities? Derived, if you look about this word derived, mean that be formed from the other combination of other something. So it's actually formed using the two or more fundamental quantities. These fundamental quantities, multiple fundamental quantities come together and combine and make the derived quantities. For example, speed, volume, density are all the example of the derived quantities. We will have the some deep examples about it in the upcoming slides. We will know about that very accurately over there. What are units in physics? Units is actually the standards for the measurements. Like it tell us about the magnitude of measurement like the it's yes, magnitude, no, sorry, it's not about the magnitude. Let's think about that. Simple definition we have: units are the standards used to express and compare the physical quantities. Like for expressing the physical quantities, we use units, and units are actually the standards for that. So, for example, we have a meter as a standard for the length, kilogram as a standard for the mass, and second as a standard for the time. These are actually the some example because we have a lot of different examples like that. So, for the example over here is this, like the meter is actually the unit, and unit is the standard expressing the physical quantities. Which physical quantities? Length. So meter is actually the unit for the length, and kilogram the same as the kilogram is for the mass, second is actually for the time. So all these are the unit standards for these physical quantities. Introduction to SI units. Let me to have or to tell you a little history about it and behind it. First of all, when on the earth, scientists of this region, for example, are measuring about something, studying about something, having their own scales, all that. This region also have something measuring scales, their own, they are using only in this region, and this region also has their own scales for measuring. This region all has their own regions for their all scales for measuring. So yes, it is good for their own region, but whenever they are introducing their studies with another region, or communicating to studying about the measurements with another region, that produces confusion over there, because for their scale is something else, for their scale is something else. That makes toward, and that goes toward the very much confusion about that. So for that, there is a conference set over there and form a system of units for the whole international world. So anywhere you are doing something, you will have a standard unit for the measurements. Or no matter if you are here, you have a same measuring scale over here, over here, over here, all that. So why it is of essential for us, or why it is beneficial for us, use worldwide, like everywhere you can use that, remove confusions, like in communication, or during communication, or during the introducing about their measurements, measurement, it become easier for us. So it reduce, or it remove the confusion about it. Easy to convert. So for that region, all that is same, so they can easily convert everything with a very good values by using the international system of units. So that's why they introduced the system international for the units, just to remove the confusion, all that. Here we have the example of the actual base quantities, the physical quantity, fundamental quantities I have told you in the previous slide, and their units. The base quantity is actually accurately 7 in number. Quantities: length, meter, symbol of that unit is m, mass, kilogram, kg, time, second, all that, something, temperature, Kelvin, luminous intensity, candela, CD, all that. These 7 are the basic base quantities, fundamental quantities, along with their units and unit symbols. These are the base quantities. Derived quantities and examples. As I told you, that derived quantities are actually that quantities which are formed by the combination of the different fundamental quantities and formulas. So using formulas. So here we have the examples of with the units. Speed is actually what we have, the distance covering in a per unit time, that we can say that is the speed. So the distance is actually the length. So the length has a meter, and then divided by time, s. Area, length multiplied by breadth. How we can finding about the area? Length multiplied by breadth, and the width we can say also. So meter. So meter, add up their powers, so meter square. Same for the volume, and same for the force. Force, as we know that force is equal to ma. M is mass and acceleration. Mass is kg and acceleration is meter per second square. So all that is about the derived quantities with examples and their units. Why use standard units? As I told you before that, just to avoid the confusion, accurate communication, international consistency, easier conversion and calculations. All these benefits, we are using the standard units worldwide internationally. So that's the very great job they have done. Quick recap. Actually, the total we have today, the lecture is going to end now. Right now, we have a little bit recap about it. Physical quantities describe measurable properties. Units give meaning to the measurements. Yes, without units, measurements is totally a number, and that number is totally meaningless for us. SI units are used globally because of their benefits, as we have discussed before that. And that it avoid the confusion, it make us internationally consistent with other internationally consistent. 7 base quantities form the foundation. Derived quantities are built using the formulas. So that's all about the today's lecture. Thank you for watching. If you found it very helpful, then please like it, share it with your friends, and told them that yes, it's here the uh, lecture over there that can about solving problems. So comment if you have any doubt. Like I will pleasure to get the comments from you. If you people have any problem, if you have any suggestions for me, I will be thankful to you. All of you, anytime, any type, all that. So and yes, the main thing, don't forget to subscribe my channel, because I will do my all best to make your physics easier, and we will go from the basics. I think it's the third lecture I'm doing. So we will go from the very basics to the very heights of the physics, inshallah, in our upcoming life. And for that, I will need your support, and I know you will support me, inshallah. And yes, if you have any type of doubt, suggestion, I'm saying again, then you can comment, or you can also uh, text me in my personal email. I will watch it, inshallah, and will reply it, and will do my responses as well in the message form and in the video form, in that in a improving form. So thank you so much, and thank you so much again for watching, for giving me time, and all that. Allah Hafiz. Thank you so much.